So as of now, I showed how to calculate the center of mass of a system of point particles that lie along one dimension or along two dimension. But how exactly do we calculate in general the center of mass of a single object with some shape? Let's suppose we have the following blob that has this shape that lies along the XYZ axis. So it's a three-dimensional blob. Now let's suppose this blob is composed, it can be broken down into many tiny square particles that each have a mass of change in m. So for example, this particular tiny particle, ith tiny particle, has mass change in mi. And the position vector, the location of the center of mass of this particular tiny object, tiny particle that composes this blob, is given by the following vector. So the r vector is simply the position vector of that tiny particle. The I simply represents, it's the ith tiny particle. And notice, because this is a three-dimensional square, that means it has the x component, the y component, as well as the z component. So this vector is the location of the center of mass of this particular tiny particle, tiny square particle. So how exactly do we find the center of mass of the entire blob? Well, we basically have to find the center of mass of all of the tiny square particles that compose our blob. So we do the following. We suppose that the blob is composed of n number of particles that each have mass change in mi, and then we find the individual coordinate point of the coordinate point, the vector of the center of mass. So because we have a three-dimensional object, that means the center of mass will have three coordinate points: the x coordinate point, the y coordinate point, as well as the z coordinate point. And what we do is we take the limit as n approaches infinity. So we're basically making these tiny particles smaller and smaller and smaller until they're infinitely small. And we take the sum of all the center of mass of all these tiny particles, and that will give us each respective coordinate point of our center of mass of the entire blob. So once again, for the x coordinate point, we take the limit as n approaches infinity of the sum of the product of the location vector and the mass of the object, and divided by the total mass of the entire blob. So let's suppose the total mass of the entire blob is capital M. It's given by a capital letter M. So we can replace the bottom of each of these with simply m. Now the top can also be replaced by integral notation, because the limit of the sum is simply the integral. So we take the integral of infinitely small change in mass and multiplied by the location x, the location vector of our object along one dimension, and divided by the total mass m. Now notice m is a constant, so we can take m out and we get the following notation: 1 over capital M of the integral of x and dm. And the same exact thing is done for each coordinate point. So we have 1 over m of the integral of y times dm, and 1 over m of the integral of z dm. So now to find the center of mass of the entire blob, we simply have to take all these coordinate points into consideration. So we replace it with the following notation. So RCM, the center of mass vector of the blob, is equal to 1 over m and the integral of all of these component points. So XCM I hat plus YCM J hat plus ZCM K hat, where CM is simply center of mass. And we can represent it in the following notation. So 1 over m integral of our r, which is simply this entire vector, multiplied by infinitely small change in mass. So once again, the capital M is the total mass of the object. Now, a related concept to center of mass is center of gravity. Center of gravity is essentially the point at which the force of gravity is considered to act. So let's suppose that we take the same blob. And let's suppose we take this same ith rectangular particle of the blob. Now, the force of gravity will act at the center of mass of this little tiny particle. And so the center of gravity will exactly coincide with this tiny particle's center of mass. So actually, the force of gravity acts on all different parts of the object. It acts at every single respective center of mass of these tiny particles. But for assumption purposes, we usually assume that the force of gravity acts at the same exact point at center of mass. So, as long as the object isn't that large, we can make the assumption that the center of mass and center of gravity of our object coincide. They're exactly the same. Now, this is not always the case because for very, very large objects, the center of mass and center of gravity will not be exactly the same.